Hi everyone. I'm going to be doing my informative speech on a history of the Earth from the Big Bang to the Earth's formation. Originally I was going to be doing it on the history of the Earth from the Big Bang to the present, but that ended up taking way too long, so I've cut it back, and this is what I've come up with. Over 1 million Earths could fit inside the Sun. There are hundreds of billions of stars like our Sun in the Milky Way galaxy. There are hundreds of billions of galaxies in the observable universe, and Earth is just one of hundreds of planets that we have observed, and what we have observed suggests there are countless more. When we're faced with numbers like these, it's easy to feel insignificant and commonplace, but I think it's these numbers that really speak to how amazing the universe is. Not that we're commonplace, but that we're special. The history of Earth is a long one that starts well before its formation, and that's what I'm going to talk about. How the atoms created in the Big Bang have come to the Earth through gravity, the creation of stars, the nuclear fusion happening within those stars, and from their eventual destruction. In the beginning, about 13.7 billion years ago, the Earth existed along with everything else in the universe in a pinpoint of unimaginable density and heat. Then something happened, an explosion of sorts. The universe began to expand at an incredible rate. Within a fraction of a second, gravity begins to have an effect, and protons began to form. And within a few minutes, those protons began to form the nuclei of hydrogen and helium. But it wasn't for hundreds of thousands of years that those nuclei became atoms of hydrogen and helium, and hundreds of millions of years after that before gravity caused stars and galaxies to form. Galaxies are enormous, and aside from the one we live in, incredibly far away. The distance of other stars and galaxies is generally measured in light years or parsecs. A light year is the distance that light travels in a year, and a parsec is about 3.26 light years. To give you an idea of the scope and what exactly those numbers mean, in 1 second, light would circle the Earth 7.5 times. It takes 8 minutes for light to reach the Earth from the Sun. The nearest star to our own, Alpha Centauri, is about 4 light years away. The nearest galaxy, however, the Andromeda Galaxy, is about 2.2 million light years away. That means that if you look at the Andromeda Galaxy through a telescope, which you can do, you're seeing it as it was 2.2 million years ago. But galaxies themselves are just collections of what we're really interested in, which is stars. Our star, the Sun, is just one in a sea of trillions, but without it, there'd be nothing on Earth. It contains 99.9% of all the matter in our solar system. That means that as big as the Earth is, and Jupiter, and Saturn, the Sun is 1,000 times the size of all of them combined. The Sun is largely made up of hydrogen, 75%, and that's its fuel source. It takes hydrogen atoms, and by incredibly high temperatures and pressures, it fuses them into helium, which releases energy. That's called nuclear fusion. As the Sun ages, it will have less hydrogen to fuse, and so it will start to fuse its heavier atoms, like helium, into even heavier atoms, like beryllium and carbon. Once a star reaches the point where it's fusing iron, however, the reaction stops producing energy and starts consuming it. This is a dying star, and though our own Sun is relatively young, it too will die. When a star dies, there are basically 2 ways it can happen, which are determined by its size. A sun like ours will collapse into a cloud of gas. This is called a planetary nebula. A much larger star, though, one 8 times the size of our own or more, will go through a process of renewed nuclear fusion, where it will create yet heavier elements, such as platinum, gold, mercury, nickel, and then it will expel them into space. These dead stars are where we get the elements that make up comets, planets, including our Earth, and even our bodies. The death of a star is not necessarily an ending. More away, our universe grows and evolves and creates, from the Big Bang through atom creation to the formation of stars and their deaths. There is a natural progression, much like the ecosystems of Earth, to be born, to grow, to die, so that the cycle may continue and the universe may change. The Earth is part of that cycle and is here because another star that may have had another planet around it exploded and engulfed its own solar system in a supernova of massive scale. It's like Carl Sagan says, we are made of star stuff. We, the Earth, everything is made of star stuff. Thanks. Have a good day.